Okay, so on page 148, we begin section 4.2, which is the properties of inequality. So if you remember from previously when we studied, you need a pencil or you need Sharpie? Yes, go ahead. We learned in 4.1 about inequalities and determining whether a solution is true or false based on numbers given. So in this one, we want to talk a little bit more about the properties. So if you remember, we had properties of addition and multiplication. We had the commutative property of addition, the associative property of addition. And so we're sort of looking at that in terms of inequalities as well. But first, I want to kind of do a refresher from our previous chapter where we worked with equality. So if you look at this first one, I've given you the equation y minus 5 equals 32. So what do we need to do to solve for y? Right, we do our inverse operation of whatever's being done to the variables. In this case, we're subtracting 5 from it. So the inverse is adding 5. And if you do it to one side, you must do it to the other. All right, and so y would equal 37. So there's our solution. What property did we use to solve that? I know. So with equations, we have the properties of equality, right? The symmetrical property of equality tells us that what we do to one side of the equation, we must do to the other. Yeah, so, well, we do that every time. But which other property did we use here? What'd you say? Yes, but it was an inverse operation of an addition. So we use the addition property of equality. That's the property that we used here. All right, so if I have x plus 7 equals 8, then in order to solve for it, we do the inverse operation of what's currently being done to your variable. So we subtract 7. And so x equals 1. So that's our solution. And what property did we use? So what is it, Andrew?
Subtraction property of equality.
Subtraction is just adding a negative number.
Addition property.
So the addition property of equality. This is an example of the same thing. So we always talk about properties in terms of addition or multiplication. Because excuse me. Can't talk and write at the same time. Hold on. Addition is adding a number is adding a positive number. Subtraction by definition is the addition of a negative number. So it's still addition. It's just your number is either negative or positive. Come on. All right. Let's look at 2 more of these. What if I had negative x divided by 4 equals 12? What is my inverse operation here? Right. You said it right the first time. -4. Throw that negative with your 4, with the constant, so it saves you a step later on. So in this case, we'll just pretend that's down here because we know if the positive is divided by a negative, it's negative. So you just throw it on the bottom. So anyway, so we multiply both sides by -4 because that's the opposite. That's the inverse operation of division. And 12 times -4 is -48. So that's our solution. What property of equality did we use there? I know it is the multiplication of property of equality. I know you transferred after we had done all this, but this is the,
I don't know.
all right. The reason it's multiplication, whether you're undoing division or not, is because essentially you are multiplying the number by its reciprocal. So x over -4 is the same thing as 1/4 x. And if that had been 4 times x, so you're really just multiplying it by -4 over 1. And that's why it's still multiplication. Even as you'll see here in a second, we do what looks like division. So for number 4, we have -3y equals 51. And so in order to isolate our variable, the inverse operation here is to divide by -3, which is the same thing as saying you're multiplying it by -1/3. I don't think so. 3 goes into 51. 3 goes evenly into 51. Because 5 times 1 is 6. So anyway, so yeah, so you can write division as dividing it times a fraction. This is really the same thing. So that's why it's, if you didn't, then it would look like this.
Okay.
I just wanted to show you, even though we're now, looks like we're dividing both sides by -3, which we are, that can also be represented by multiplying it times the reciprocal of 3, which is 1/3.
I'll just use my gigantic brain memory.
Yeah, use that big brain. No worries. But that's why we still call it, let's see, 3 goes into 5 2 times, and then 3 goes into 21 7 times. So no, that's not right. Is that right? That's not right. It's 17. I am not the one in the room with the big brain. So we're still using the multiplication property. Okay. So let's look at the actual instruction that you have for this section. So in this case, they're talking about properties in terms of inequalities, as opposed to the equations, which are equalities. Still fairly similar, but there are some very important differences that I want to make sure we're aware of as we go through this. So inequalities are solved using properties similar to the properties of equality. Adding or subtracting the same number on both sides of an equation yields the equivalent equation. And they give us a case here. So they give you the case of, is 5 less than 7? Yes, 5 is less than 7. What if I added 2 to both sides? Is my inequality still the same? Is 7 still less than 9? So no matter what I add or subtract to both sides, so let's look at, what if I did 5 minus 3? Is that still less than 7 minus 3? Which is essentially what I'm doing there, is I'm saying 5 plus -3. That's why we still call it the addition property, even when we're subtracting. Well, then I'm still have 2 is less than 4, which is still a true statement. So the equality part, that's the symmetric property of equality. As long as you do the same thing to both the left side and the right side of an inequality, your inequality will stay the same. Okay, with addition. That's going to change a little bit when we look at the multiplication property of inequality. All right, so it gives it to you in a statement. We'll look at some examples because they make more sense to me than words. But what it's saying is, if you have a number A, a number B, and a number C, and they're all real numbers or expressions such that A is less than B, then if you add the value C to both A and B, it's A plus C is still going to be less than B plus C, which is what we just looked at right here. All right, so let's move on to the first one. Let's look at example 1. So what they want in example 1 is they want you to solve and graph the solution to each of the following inequalities. So let's look at this. Example 1, and there went my pen. On page 149. Number A gives us x plus 7 is less than 8. All right, so what do we need to do to solve for x? What do we need to do, Gabe? It's just like what we do with equations. What's currently being done to x? Right, so what? Right, so what do we do? There we go. From exactly. Your inequality stays the same. So x must be less than 8. No, that's not right. Why'd you say 8? That's what I mean. 1. All right. So yes. So x, in order for this inequality, x plus 7 is less than 8. Then that means x must be less than 1. Which is true, right? Because 1 plus 7 is 8. And is 8 less than 8? No, it's equal to, right? All right, and so they want us to then graph it. All right, so if we graphed x is less than 1. All right, put 1 right here, 2, 0, -1. So where does the beginning of my graph go? On at 1, open or closed? Does it include 1? Right, remember it's closed if it's equal to. It's open because that means we start at 1, but we don't include 1. Because 1 is not true. And then you move left because it must be smaller than. So that means that any number less than 1 gives you a true statement that makes that inequality true. All right, let's look at B. So B is x minus 5 does not equal 3. All right. So girls, either one of y'all want to suggest what do we need to do to solve for x? We want to add 5 here and here, right? So x cannot equal 8. Which if we plug that back in, of course, you can always, just like with equations, you can always plug that value back in and make sure it's true. So if I have 8 minus 5 does not equal 3. What's 8 minus 5? That's 3. That's not true, which means that my statement x cannot equal 8 is true. Because when I plug 8 in, it gives me a false statement. That's why the negations are weird. That's why we always try to convert those if we can. But let's graph that. So if we graph that, we get our number line, put a couple of tick marks on it, throw an 8 in there somewhere. 9, 7, 6. All right, so where does our circle go? Where does the beginning of our graph go? On the 8, is it open or closed? Right, it's open because it doesn't include 8. Which way does my arrow go? Exactly, it goes both because it can be any number greater than 8 and it can be any number less than 8 as long as it's not 8. And that's our solution. All right, the last one just includes the equal to. So let's go ahead and do C. And then we'll look at what time is it? Yeah, we got time. Then we'll look at the multiplication property. Okay, so for C, we have -0.6 is less than or equal to? Yes, less than or equal to x minus 0.4. Okay, so what do we have to do here to isolate our variable? Anybody? Huh? Do what? Anybody?
He's asking.
Andrew? What do I need to do to isolate my variable?
Okay. Okay, you need to add 0.4
Perfect.
to both sides. Why did that get just thrown on me?
I don't
I don't
know.
even have that one written down.
Were you still working through the previous one?
I was still writing it down, yes, so it looks neat.
Good job.
Because if I don't, it's just like.
Hot mess. And you have no idea what you wrote. I know. It's
What's
okay.
my header?
Okay. Refocus.
That explains a lot.
So what's right? What's negative 0.6 plus 4.4? Negative 0.2. I don't look. I gotta do what I gotta do. I'm struggling. Okay, so let's graph this.
Okay.
So what we've determined is that x must be, and I would rearrange this, right, and just flip it. Put your variable on the left side, which means you flip your. It is. It's what we call math etiquette. You always put your variable. Variable equals value. All right, so we have this guy.
So we need to start with negative 0.2. Behind that is negative 0.3, and in front of it is negative 0.1.
What is behind it and in front? Left or right?
Left is behind.
So
Right is
this
in
is negative 0.3, negative 0.4.
And then
Go with 0 there. All right, yes, so our graph starts at negative 0.2. Open or closed?
close.
Yes, exactly, because negative 0.2 can be a possible solution because of the equal to. All right, and then which direction we go, left or right? Right, we must get larger. So as long as x is equal to or greater than negative 0.2, you're gonna get a true statement with that original inequality. Okay, so then we need to look at multiplication. So the case that they give us, case 1 and case 2 on page 149, again, is 3 less than 5. True statement, right? So, yeah, it's Wednesday. So let's say I multiply 2 times 3 and I multiply 2 times 5. Is my statement still true?
Yes.
Is 6 still less than 10? Yes, even more so when you're multiplying. So that's true. And then of course, if we have 3 is less than 5, and this is where it gets fun. And we multiply both sides by negative 2. Because what happens when we multiply a positive times negative? Yeah, or anything times a negative. If you multiply a negative times a negative, your answer becomes positive. If you multiply a positive times a negative, your answer becomes negative. So your answer is always going to switch signs no matter what it is originally. What that means is negative 6 is no longer less than negative 10. So whenever you multiply or divide by a negative, you must flip your inequality. So negative 6 becomes greater than negative 10. This is the biggest key to remember with the multiplication property of inequality. So they give that to you at the top of page 150. It says that if A, B, and C are real numbers, they're just any number. That's not imaginary, because there's those. Our real numbers are expressions such that A is less than B And then you have, so this is your if then statement. So if C is greater than 0, yeah, go ahead. AKA positive, then A times C is still less than B times C. Okay. But if C is less than 0, which means it's a negative number, negative, forgot how to spell, then A times C is greater than B times C. Okay. And remember, when you're dividing, it's still a form of multiplication because you're just multiplying times a reciprocal. You're turning us like a whole number into a fraction or vice versa. So it's still multiplication. So this process still applies. So you can think of it in terms of multiplication and division. If you multiply or divide by a negative number, flip your inequality. Okay. They give us some examples, but why don't we just do some practice? I'm going to go ahead. What do I want to do here? Yeah, let's go ahead and work through the homework problems. We'll do the additional problems tomorrow. Because it's Wednesday, y'all don't have homework tonight. So this saves you from having to do this for homework tomorrow night, hopefully. So let's go ahead and get through some of these so we can get some practice. And then tomorrow I'll introduce some additional problems for you guys to have as examples, and we'll finish the homework so we can make sure we understand this. So the total homework assignment we're going to do for this. Hold on, I keep looking at pre-algebra. All right, 2 through 32 even. So page 151. And I would say you're doing things the hard way, so don't. All right, so number 2. Okay, so in the case of 2 through 8, we need to solve and then graph the solution of each of the following inequalities. So Aiden, I'm going to start with you. Let's look at number 2. We have x minus 2 is less than or equal to 3. So what do we need to do? Just like with equations, we need to isolate our variable and set up a value for x. Right, so we add 2 to both sides, the addition property of equality, and we get x, or inequality in this case, x must be less than or equal to 5. Right, so when we graph it, 1, 2, 3, 4, 5, I'm going to throw 5 in the very middle, 6, 7, 4, 3. Where does my graph start? All right, is it open or closed? Closed, because it's equal to. And then what direction does my graph go in? To the, yeah, it gets down. It's down, right? X must be less than 5, less than or equal to 5. So it can be 5 and then any number smaller than 5. All right, Gabe, number 4 is going to be yours. What do we have here? So in this case, we're going to be using the multiplication property of inequality. So what do we need to do to isolate our variable? Right. How do we undo the 4? What's currently being done to the x? So the inverse operation of multiplication. There we go. So we need to divide on both sides. So because we're dividing or multiplying, in this case dividing, look at the number you're dividing by. Is the 4 negative? Okay, then we just don't worry about our inequality sign. It stays just like it is. Okay, so x must be greater than what? negative 2/4, which simplifies to what? Yep.
Wait, so we don't divide it that way?
Well, we did. So you can either put your answer as, it's 4 divided into 2 though,
Yeah. So
and 4 is larger. So your answer is either 0.5 or, as Eden correctly said, it's 1/2. But you got to make sure it's negative. So you were just looking at it backwards. That's all. So let me clean that up. X must be greater than or equal to, because we're about to graph this on a number line, I would make it a decimal. And since we've already studied percentages, we know that 1/2 is, or in this case, negative 1/2 is negative. Yes.
it's not good.
Why wouldn't it be? It's okay. No, that's a good question. Oh, it's not equal to, you're saying. Yeah, you're right. I added that. Did I add that in?
It's not there on the paper.
No, you're right. It's not. I was looking at
That's
it
why I was confused when you said, why wouldn't it be? I was like,
because it's not at the beginning, so
Yeah,
it can't
sure.
automatically become equal to. No, you're right. Telling y'all. We all know how I struggle. Okay, so let's put it on a number line. Okay. Just keep these in decimal. Or you could do 0.5, 1.1, 1.52, whatever you want to do. Keep them as decimals. Okay, so negative 0.5, negative 0.4. Just remember, because this is negative, the smaller the number gets, the larger its value. Negative 0.6, 0.7. All right, so where do I start my graph? At the negative 0.5. And is it open or closed? Why? It's not though. That was a mistake. Does this contain the equal to? Right. So it's open, so it starts at negative 0.5, but it doesn't include it as a viable solution. And then does it go to the left or to the right? Bigger or smaller? Right. So it's going to the right because X must be greater than negative 0.5. All right. Number 6, Andrew says negative X divided by 2, or X over 2, is less than 4. Sure thing. Take your time.
well, I was just going number 8.
You went to number 8.
Yeah, I see. 6, you have to multiply both sides by -2,
Yes.
and you get X is less than -8.
So you have X is less than -8. So when we multiply by a negative number, what do we do with our unequal?
Switch the sign.
Right, we've got to flip it. So because because the number we're multiplying both sides by is negative, you must reverse
I
your,
was thinking there was something like that.
yes. And that's what I thought you were asking about earlier when I just randomly added an equals to my greater than. Yeah. So exactly, you must flip your inequality sign when you multiply or divide by a negative number. So now we have this correctly and we can throw it on a number line. One.
-8. And then to the left of -8 is -9, and to the right of it is -7.
Okay, and our graph starts where?
That's a -8.
Open, because it's not included. It goes to the right because it's any number larger than -8. Perfecto. All right, Abigail, number 8. What do we got here? We have X minus 8 is greater than or equal to -8. Okay. All right, so what do I need to do to isolate my variable? We add 8 to both sides. And what do we end up with? Hmm? Is it, so what's 8 minus 8? That's the same thing as -8 plus +8. Right, we find the difference. So x must be greater than or equal to 0, which is fine. You throw a 0 on a number line any day. So 1, 2, 3, 4, 5. So 0, -1, -2, 1, and 2. All right, so our graph starts at, and is it open or closed? It's closed because 0 is included. It's equal to. So we have a closed circle, and then should x get bigger or smaller? Bigger. Yeah, so we move to the right. Okay. All right, we'll do one more and then we'll call it a day. Number 10, Eden. All right, so now we're also starting a new section. It's just, okay, so in this case, we don't have to graph it, we just have to solve it. Nice. All right, so for number 10, I have y minus 26 is greater than 82. Well, you have to get rid of the minus 26. Exactly. Inverse operation, yes. So we're currently subtracting 26 from y, so we have to add it to undo it. And so we're left with y is greater than 6 plus 2 is 8. 8 plus 2 is 10. So your solution is that y can be any number as long as it's greater than 108. That's what this says. All right. So we'll finish these up tomorrow, give you some more examples, and then we actually, today's Wednesday. That's right, we're a day behind because of art. So we will do a quiz review on Friday. And then we have a quiz on, that means we have a quiz on Monday. Sorry. But I'll make sure, I don't think this is hard. Y'all have seen these before, we'll be okay.